Hello, it's Professor Troy again. I'm going to show you now how to use the electromagnetic tracking system. So this is a Polhemus G4 system, and it basically consists of a source, which is here, and then several sensors, which look like this. And each of these sensors are attached to a hub. So all of the supplies for the system are kept in this nice Tupperware container here, and that includes this very important RF dongle, which needs to be plugged into the computer, and then all of the sensors, and then the power supply to the source. Okay, so first things first, the source sits, whoops, I guess this is sideways. Anyway, the source sits on a tripod here, and it gets plugged in right there, and then of course the other end gets plugged into power supply. Okay, and then you can just turn it on with this switch right there, and you can tell it's on because the blue LED is on. Okay, the thing to note about the source is that it does have axes, so hopefully you can see, let's see if I can get out of the light here. Anyway, you can see here's the plus X direction, here's the plus Y direction, and in this case the plus Z direction goes down into the floor. So one thing that you'll want to do is take a level and put it on this box to make sure that the box is horizontal, because, and then if you're collecting force plate data concurrently with this, you want to make sure that the force plate X and Y axes are aligned with these X and Y axes so that you know how they're related to each other. Okay, the other thing you want to know is that the force plate is going to be located in space. So 0, 0, 0 in space is this coordinate, is this dot right here. And so you need to actually take and measure down to the floor wherever your force plate is so that you know what the offset is from your force plate 0, 0, 0 to the electromagnetic tracking 0, 0, 0. Okay, so I'm going to walk over here. We keep the hubs, which look like this, over here charging. Okay, so this is a little charging station here by the printer, and it's really important that the hubs get put back and are charged up. Okay, so you can see this one here is basically they're on USB chargers, and this is where they need to stay all the time. So we'll just take one of these. Okay, so what happens is the sensors here, they plug into the hubs. Let's see here. So you can see here's sensor labels. Okay, so what we're going to do is we're going to plug it into sensor 1. I apologize. Okay, that was unsuccessful, but I did plug it in. Okay, so now it's plugged into sensor 1. That, by the way, is where the USB charger plugs into the hub. Okay, and then what happens is, after you fail to break this off, okay, so usually there's a little clip here. Okay, so there's the clip, and so whoever's having data collected on them, they can just wear this little clip so they can actually clip the hub to themselves. Okay, so what happens is the sensor tells the hub where it is, and then the hub actually needs to talk to this RF dongle. So this dongle needs to be plugged into the computer. So we tend to use this machine, which is over in the corner by the biohazard box. And if you go over here, the RF dongle just plugs into the USB. Now I have it on a cord because what I've noticed is that if the distance between the dongle and the hub is too great, then they don't do a great job of talking to each other, and then you tend to lose a lot of data. So that's one easy thing to troubleshoot, is that if for some reason you find your data are not streaming very well, you probably need to take this and just move it a little bit closer to wherever your person is who's collecting the data. And usually somewhere around, say, 2 to 6 feet away is a good way, it's a good distance to be. Okay, and then same thing here, the source here really has a range in which it's accurate, and it's also about a 6-foot range. So you can think about sort of drawing a 6-foot sphere around this box, and that's sort of the data capture range that you have. Okay. So the measurement program that you'll use is a program called Pi Manager. I don't know why it's called Pi Manager, but it is. And so if we open this up, basically what we see is a screen here. So this is going to tell us where our hub is, and it's going to tell us where everything is in space. So what I'm going to do here is turn on our hub. Okay, so if I turn this on, see this little light, now it's blinking. Okay, and now I think it should have found itself. Okay, so if it stops blinking, now it should know where it is in the world. And if I go back up here, you see Hub 1, Sensor 1 has appeared in my Pi Manager, and down here, this little airplane has appeared. Okay, so up here, so when everything works well, this is how the system works. And I will make a separate video that shows all of the various ways that you can troubleshoot it. This is just it's working well and how do you use it. Okay, so the one thing you do want to do is you want to open up a configuration file. Okay, and I made one here in December, which you can use. So you just hit open. Okay, I'll point out too, it's in Program Files, Polhemus, and then G4. And also this monitor has problems, so it'll blink back in a second. And now my computer, okay, here we go. Come on. Okay, there we go. Okay, so I'm gonna hit open. Okay, now, if I just wanna see what's going on, I hit this. Okay, and now you can see there's this whole mess of data that's streaming in front of me. Okay, and this actually looks pretty good. And then when I look down here, I can see this little airplane. Okay, and what I'm gonna do over here is grab my sensor, and I'm just going to twist it around like this. Okay, and when I do that, I can come here and look at my airplane. Okay, you see how my airplane's moving, right? That's pretty cool. And if I move my sensor back and forth, right, I can see that my airplane's moving back and forth. And when I look over here, hopefully you can, if the monitor didn't keep blinking out, hopefully you can appreciate that the numbers were actually changing. Okay, so here again, if I can move it down, you can see it going up and down in the Z direction. So here I'm going lower, and here I'm going higher, okay? And then if I move it in the X direction, right, now I can see that mostly it's my X numbers that are changing. Here they're at like 33, and here they're down to 11 or 10. And then I can also change my Y direction. So here I'm going down to 15, and then back up to 36. Okay, so what I'm doing when I do that is I know that my Y direction is this way, and my X direction is in and out of the screen, and my Z direction is up and down. So that's a really good way to troubleshoot and make sure that your sensors are actually working properly. Okay, so what I'm going to do here is just toggle that stop, and I want to orient you a little bit to the numbers here. So when you actually save data files, what you're going to see is these numbers. Okay, right now I think they're reported in inches, and these are literally the X, Y, and Z coordinates of your center as in the sensor or in the source coordinate system, right? So basically there's a coordinate system here that the source sets up, and it's got X, Y, and Z coordinates. So it's just literally reporting back the position. The second three numbers here are actually the orientation in terms of degrees. So they basically tell you how your sensor is actually rotated about the X, Y, and Z axes respectively. In the skeletal biomechanics lab, we're not really going to deal with these numbers too much, although you can certainly use them, and they give you a lot of information about position. So if you're interested in using them in the future, you're certainly welcome to have a word with me. The other thing that this shows here is this is Hub 1 and Sensor 1. So we can actually now real-time add on a second sensor. Oops. Okay, so here's an extra sensor. And I apologize, I know you can't see anything. Okay, so what I just did was I just plugged in a second sensor. Okay, so here's my sensor 2. So now I'm going to look over here, and hallelujah, look at that. So now it has Hub 1 Sensor 1 and Hub 1 Sensor 2. Okay, and if I go over here and I stream now, okay, hopefully you can appreciate the fact that now it's alternating 1 and 2. Okay, and again, if we take a quick snapshot, now you can see there's Hub 1 Sensor 1, which is right here, and then there's Hub 1 Sensor 2, which is down here, and it's giving me the positions of each one. Okay, so what do you do with this thing? Well, ultimately you probably want to record data. So there's a little recording toolbar here. That's saved as part of the configuration file that it shows up. If for some reason you find that it's missing, I think you can go to View, and then here, Toolbars, and then you can click Data Capture Toolbar. Okay? And so what you want to do in order to record data is you first stream the data. Okay, so now it's streaming. Then you're going to hit the red record button. Okay, now it doesn't stream while you're recording. Okay, so I know that's tricky and it's a little stupid, but that's the way it goes. So then you just hit stop when you're done. Okay, now it's streaming again. Okay, you want to turn that off. And then what you need to do is save it. Okay, so I'm going to hit save motion recording. Okay, so you can see I've already got a file named test, but I'll name this test 2. Okay, so now I have this file and it's saved as a .tmot file, so I can actually load it in my Pi Manager, so that's called a Pi Tracker motion file. Okay, and since my two files weren't really, or since my two sensors weren't really doing anything, now I can go over here and I can actually play it back to myself by hitting the play button. Okay, and sure enough, there's my two sensors, and they were just laying on the table, so it's not very exciting at all, right? Okay, so that's not super useful, but what you probably want to be able to do is actually do something with the data, and to do that you have to export it. Okay, so you go to export motion recording. So again, here now I can save it as a text file, or actually probably as a CSV is a little nicer. Okay, so now it's test2.csv. Okay, and I'm going to save it. Okay, so let's take a look at that. And of course the big question is, where did it save it? Right? Always one of the big mysteries in life. And the answer is, let's see if we can find it. I'm going to look in my C drive, I'm going to look in Paul Hemus, it's not there. So the next thing I'm going to do is look in Program Files x86 and Paul Hemus and Pi Manager, and let's see, not there. That's exciting. We'll look in G4. Oh, hey, look at that. Okay, so it happens to have ended up here in C drive, and then Program Files, and then Paul Hemus, and then the G4. Okay, so here's my test 2. So if I open this up, just a moment. Da-da-da-da-da. Okay, so here again is the exact data that I had before. The one thing that you'll see here now that we can actually get a good look at it is this column here. So you can see this is like 101,670, 101,671, 101,672. So this actually refers to an arbitrary measurement number. What you need to know is that each of these measurement numbers is separated by 120 hertz. So now you can actually assign a time value to your data by looking at when the measurement was taken. And what you'll find is that sometimes there are data points missing if for some reason your hub and your dongle don't make a very good connection. So I have a little MATLAB routine which I have put up on the Blackboard website for the class, which actually takes this data, which right now is in a very annoying format, and it basically reorganizes it so that you have a time series for each sensor, right? So you can see in this case sensor 1 is going 14,442, 14,442, 14,443, right? That's this one sensor, but the other sensor is interspersed into it. So we can fix that. But anyway, this is the type of data file that you'll want to save so that you can read it into MATLAB and then figure out what you want to do.